From Space Launch Complex 41 at Cape Canaveral Air Force Station, United Launch Alliance presents live Atlas V launch coverage. On board, MUOS 2, the second Mobile User Objective System satellite for the United States Navy.
Range go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 9 minutes 24 seconds and counting. Launch countdown operations are continuing, and the team is not working any issues at this time. The window for today's launch opens at 8:48 a.m. Eastern Daylight Time and will remain open for 44 minutes, closing at 9:32 a.m. Eastern Time. Good morning, and welcome to Mission Control here at the Atlas Spaceflight Operations Center at Cape Canaveral Air Force Station. I'm Steve Agate, and I'll be your countdown commentator for today's mission. Following liftoff, you'll hear the voice of Matt Donovan, providing launch vehicle ascent data. Also, later in the broadcast, I'll be joined by Commander Matt Boland, the Principal Assistant Program Manager for the U.S. Navy's Communications Satellite Program Office. MUOS 2 delivery on orbit is scheduled to take place nearly 3 hours after liftoff. However, our live coverage will conclude approximately 25 minutes after launch. A planned 10-minute built-in hold will occur at T-minus 4 minutes. This hold will allow launch conductor Scott Barney and his team to address last-minute tasks. However, at this point, we remain on schedule for launch at 8:48 a.m. Eastern Daylight Time. As I just mentioned, Atlas V is launching the second satellite in the Navy's MUOS constellation. For nearly 35 years, Atlas launch vehicles have supported the U.S. Navy, launching 20 missions, including the Fleet SATCOM, EHF, and UHF Follow-On satellites. MUOS 1 was delivered to orbit by an Atlas V on February 24, 2012. The MUOS constellation replaces the legacy ultra-high frequency, or UHF follow-on system, and delivers secure, prioritized voice and data communications, a first for mobile users who need high-speed mission data on the go. Leveraging 3G mobile communications technology, MUOS provides military users 10 times more communications capability over existing systems. The MUOS team is led by the Navy's Communications Satellite Program Office. Lockheed Martin is the prime contractor. Recently, the launch team received a final weather briefing and was told the weather is within the launch commit criteria for this morning's launch. The weather briefing provided the following information. Probability of violating launch constraints, 20%. The ground winds are between 8 and 9 knots. Winds are out of the southeast at 160 degrees, and the upper level winds are nominal. The temperature, 78 degrees Fahrenheit. So, we are proceeding towards liftoff with a planned T0 of 8:48 a.m. Eastern Daylight Time. ULA is using the Atlas V 551 configuration to launch the MUOS 2 mission. This is the 39th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August 2002, and the 4th flight of the 551 configuration. Today's Atlas V launch vehicle is produced in Decatur, Alabama, and Harlingen, Texas. It is comprised of a common core booster, and it's powered by the NPO Energomash RD-180 main engine, 5 Aerojet solid rocket boosters, and a Centaur upper stage powered by the Pratt & Whitney Rocketdyne RL-10A engine. The MUOS satellite is encapsulated within a RUAG Space 5-meter diameter payload fairing that protects it during ascent. The MUOS 2 satellite was encapsulated in its payload fairing on June 26th. The encapsulated payload fairing was transported and mated to the Atlas V booster on July 8th. The Atlas V is prepared for launch at the Vertical Integration Facility, or VIF. The VIF is located approximately 1/3 of a mile south of the launch pad. 2 days ago, the fully integrated Atlas V on its mobile launch platform was rolled from the VIF to the pad at Space Launch Complex 41. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes about 30 minutes to complete. The Atlas V rocket stands 206 feet tall, or about 19 stories. It weighs nearly 1,300,000 pounds fully fueled and produces approximately 2.5 million pounds of thrust at liftoff. For those of you who are watching the broadcast, you're looking at the video taken Wednesday at Space Launch Complex 41. This is Atlas Mission Control at T-minus 14 minutes, 6 seconds and counting. Preparations for this morning's launch are continuing. As I mentioned earlier, the launch team will soon enter a planned 10-minute built-in hold. At this point, the team is not working any issues, and liftoff remains on schedule for 8:48 a.m. Eastern Time. And we have entered the built-in hold. MUOS 2 satellite is the heaviest payload to ride into space atop any of ULA's Atlas V launch vehicles. The Atlas V will generate more than 2.5 million pounds of thrust at liftoff in order to meet the demands of lifting the nearly 7.5-ton satellite. From its vantage point in geosynchronous orbit, the MUOS 2 satellite will cover approximately 1/3 of the Earth's surface and use its 14-meter diameter reflecting mesh antenna to communicate with ground-based users. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of the ground-based cameras. While the team completes launch final preparations, let's take a closer look at today's flight.
The following profile details the important events of this mission using approximate time.
Status check.
Go Atlas. Go Centaur.
This is Atlas Mission Control at T-minus 5, 4, 3, 2, 1. And the RD-180 engine roars to life and liftoff.
The Atlas RD-180 main engine and 5 solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 34 seconds. At 45 seconds, the vehicle experiences maximum dynamic pressure. The first 2 solid rocket boosters, or SRBs, are jettisoned at 1 minute 43 seconds, followed a second and a half later by the remaining 3 SRBs. At 3 minutes 12 seconds, the payload fairing is jettisoned. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 1,650 pounds per second. Traveling at approximately 13,525 miles per hour, and located 87 miles in altitude and 261 miles downrange. Booster engine cutoff occurs 4 minutes, 21 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters an 8-minute coast phase. At just over 20 minutes into the flight, the Centaur main engine is restarted. This burn will last nearly 6 minutes. Following the second Centaur main engine cutoff, at just over 26 minutes, the mission enters a nearly 2.5-hour coast phase. The Centaur main engine is restarted for a third and final burn at 2 hours, 49 minutes. Following a 59-second burn, the Centaur main engine is shut down. At 2 hours and 53 minutes, Centaur releases the MUOS satellite for the United States Navy.
This is Atlas Mission Control at T-minus 4 minutes and holding. The range has just announced that it's currently red on upper level winds. So there is a weather delay due to upper level winds. The new T0 time is being evaluated with the launch team. We'll be back to you as soon as we have more information. Again, the range is now red on upper level winds. A new T0 time is being evaluated with the launch team. This is Atlas Mission Control at T-minus 4 minutes and holding.
LC Redline Monitor.
Go Redline Monitor.
Redline Monitor and event table are in the correct configuration for terminal count.
Roger.
SATCOM check, channel 1.
Loud and clear.
LC LD on channel 1.
Go LD.
LC load contingency address file underscore AV040 _07.
Roger. Flight control LC.
Flight control.
Load contingency adjust tech hex file, adjust AV040 _07.
Copy _07. Active. Work.
RFFTS LC Net 1.
Dorf, go ahead.
Step 1790, apply onboard video power.
Roger.
LC LD on channel 1.
Go.
Please coordinate a new C0 for 12:56 Zulu.
LD LC.
Go ahead, LC.
Yeah, I'm going to need to extend beyond 1256. I need 1258 minimum.
Roger, stand by, LC.
This is this is a This is Atlas Mission Control at T-minus 4 minutes and holding. At this time, the launch team is evaluating new balloon data that has just been received, and after that evaluation is made, if everything looks well, we will pick a time to resume the count, and at that point we will get back to you to inform you of the latest information. At T-minus 4 minutes and holding, this is Atlas Mission Control.
Loaded into the FTINU and verified.
Roger. Flight control, perform launch on time verification.
Roger.
LC switch to ready position.
LC, LD channel 1.
Go LD.
LC, please coordinate a new T0 for 13:00 Zulu.
Roger, 1300 Zulu.
Roger.
RC, LC.
LCRC.
Coordinate new T0 1300 Zulu.
New T0 1300 Zulu and work.
Timer, set clock to 1300 Zulu.
This is Atlas Mission Control at T-minus 4 minute and holding. The further evaluation of the launch wind data is good. We have established a new T0 time. The new launch time is 9 o'clock Eastern Time. That's 9 o'clock even Eastern Time, which means we'll pick up the count at 4 minutes before that, 8:56 a.m. Eastern Time.
GC on net 1.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned hold as preparations for launch continue. Launch conductor Scott Barney will poll the team in a few moments for the final go to resume the launch countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team.
LCRC1.
Go RC.
New T0 1300 Zulu is approved.
Roger. Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GC.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Range, weather, and clear to proceed.
Go.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count.
Polling is complete and the launch team has been given the go for launch. The countdown will resume at T-minus 4 minutes, approximately 2 minutes from now. From T-minus 4 minutes until launch, you'll be listening to Launch Conductor Scott Barney and his team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure the Atlas LO2 topping. At T-minus 2 minutes, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activities. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. At T-minus 40 seconds, the Atlas tanks will be verified at flight pressure, followed by the verification of the Centaur tank pressures at T-minus 30 seconds. A final status check of Atlas's Centaur and the MUOS satellite is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
This is Atlas Mission Control at T-minus 3 minutes 53 seconds and counting. The countdown clock has resumed and we are go for launch at 9 a.m. Eastern Daylight Time.
T-minus 3 minutes.
Reduce ECS for launch.
Roger.
Securing LO2 topping.
Atlas tanks to flight pressure.
250. FTS internal.
This is Atlas Mission Control at T-minus 2 minutes 10 seconds and counting. The countdown is on track as we proceed towards T0. Once the rocket lifts off, it'll take about 34 seconds to reach Mach 1, or the speed of sound.
$150.
Securing Centaur LH2. Launch sequence started.
Securing Centaur LO2.
140.
Launch enabled.
This is Atlas Mission Control at T-minus 1 minute 28 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch. This is Atlas Mission Control at T-minus 1 minute and counting.
Stable at step 3. ECS reduced for flight.
Roger.
25.
Status check.
Go Atlas.
10. Go MUOS.
20.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4. We have main engine start. We have ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the second Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You'll be hearing the voice of Matt Donovan providing launch vehicle
and we are in
data.
the zero angle
Let's
of
listen
attack
in for
phase of
mission
flight.
progress.
The booster roll program has been completed. We've hit Mach 1. Now going through the region of maximum dynamic pressure. The vehicle is throttling back up at this point. Engine performance continues to look good. Booster has gone closed loop. And we've now throttled back down in preparation for SRB burnout. And we have SRB burnout. Looks good. The vehicle is continuing nominally. And we are now throttling back up to our 2.5G segment. We have SRB jettison, good indications of jettison on the first two and the next three SRBs. Q alpha steering is now enabled. Vehicle continues right down the middle of the range track. Current altitude, 41 miles, distance downrange, 49 miles, and velocity of 4,765 miles per hour. RD-180 engine operation continues to look good. Engine hydraulics are at the expected levels. We've now reached our 2.5G segment of flight. We've seen pressurization of the RCS system. RD-180 engine performance continues to look good as we prepare for payload fairing jettison. And we have good payload fairing jettison and CFLR deck jettison. Everything continues to look good. Vehicle is now throttling back up to reach our 4.6G constant acceleration phase. We've reached our 4.6G constant acceleration phase of flight.
Boost phase chill down has begun right on time. Pogo's been fired. Boost phase chill down has been completed successfully. We have BECO. Retros are fired and stage separation, good separation. We have pre-start and fuel, pre-start on locks. RCSG and 2 purge has been completed. We have ignition and full thrust on the RL-10. RL-10 chamber pressures look good. Steering has been enabled. Centaur PU has gone to fixed angles. RCS thermal conditioning firing is taking place during the burn as expected. Current altitude, 117 miles. Downrange distance, 529 miles, and we're traveling at a velocity of 13,787 miles per hour. Centaur LO2 and LH2 tank ullage pressures continue to look good. Vehicle body rates look good as well. Centaur main battery voltage is holding at the expected level.
This is Atlas Mission Control at T plus 5 minutes 46 seconds into the flight. We've just heard Matt Donovan report the successful execution of events comprising the early part of today's mission, and all systems continue to operate nominally. The mission is currently in the first of 3 Centaur engine burns. Our next event, the Centaur main engine cutoff, will occur in approximately 7 minutes. I'm now joined by Commander Matt Boland from PMW 146, the Navy Communications Satellite Program Office. Commander Boland, thanks for joining me.
Thanks, Steve. It's a pleasure to be here.
Could you briefly explain where MUOS fits into our nation's space portfolio?
Sure. MUOS, or Mobile User Objective System, will provide global UHF tactical satellite communications for mobile warfighters around the world. The MUOS constellation was designed and will be operated by the U.S. Navy to support the unified commands and joint task force components, the Department of Defense, and non-DoD agencies. MUOS provides global, beyond line-of-sight communications to the tactical warfighter in the ultra-high frequency, or UHF spectrum.
Could you explain the unique features and capabilities of the MUOS satellite?
Sure. MUOS supports a worldwide multi-service population of narrowband users. A great feature of the system is that each satellite has both legacy and the WCDMA next generation UHF payloads to support a graceful and seamless transition to the new technology while providing and maintaining UHF communications for thousands of current users. The system is designed to support those users that require greater mobility with higher data rates and improved operational availability and on-demand access. MUOS will provide greater than 10 times the system capacity of the current narrowband constellation by bringing the latest mobile technology such as simultaneous voice and data, and does so in challenging environments such as double canopy foliage, urban environments, high sea states, and all weather conditions. Legacy users will also see improved availability and better voice quality. The MUOS satellite will be in geosynchronous orbit about 22,000 miles above the Earth. From that altitude, it can see about 1/3 of the Earth's surface and uses a 14-meter reflecting mesh antenna to communicate with users on the ground.
Commander Boland, how many satellites will complete the MUOS constellation?
The MUOS constellation is comprised of 4 operational satellites and then a 5th on-orbit spare. The system also includes 4 ground stations that are strategically located around the globe. These 4 ground stations provide MUOS with worldwide coverage and the ability to connect any set of users, regardless of where they're located. As the core of MUOS, the ground system is responsible for transporting user data, managing the worldwide network, and controlling the satellites.
Commander Boland, how did the Navy get involved in providing communications capabilities, and are these capabilities used by all branches of the military?
Well, Steve, the Navy's been involved in space exploration and satellite communication since the dawn of the space age. Satellite communications has always been important to the service as a way to communicate with deployed ships around the world. And for several decades now, the Navy has had the requirement to provide narrowband satellite communications to all the services in the DoD. MUOS is the next generation constellation to fulfill that requirement. All 4 services currently have plans for extensive use of the capability we are providing.
Commander Boland, thanks for that great information. Now let's get back to the mission.
RL-10 performance continues to look nominal as we have approximately 1 minute remaining in this first burn.
This is Atlas Mission Control at T+11 minutes 32 seconds into the flight of the MUOS-2 spacecraft, and all systems continue to operate as expected. The mission is currently located over the Atlantic Ocean just east of the Antigua ground station. Our next event, the first Centaur main engine cutoff, or MECO-1, is scheduled to take place in about 2 minutes. Here's Matt Donovan.
And Centaur has achieved IIP vanish as planned. And we have MECO. MECO-1, everything looks good. Thrust chamber pressures come down as expected.
This is Atlas Mission Control at T+12 minutes 33 seconds into the flight. The MUOS-2 mission is currently in a coast phase over the Atlantic Ocean off the east coast of Africa. Our next event is the second start of the Centaur RL-10 engine. This event is scheduled to take place in approximately 7 minutes. While we wait for the next event, let's take a look at some video highlighting the MUOS capability.
Reliable communication is not only important, it's absolutely critical for effective warfighting today.
Reliable communication is the backbone of today's military. Without it, the lives of our soldiers are at risk. And just like mobile communication users worldwide, the U.S. military depends on targeted communication on the go. Born born from the need for stable 24/7 ship-to-shore communication that could be successful regardless of environmental and geographical conditions. The Navy is assigned the responsibility to provide this vast capability known today as narrowband satellite communication.
The role of narrowband communications in the overall military SATCOM architecture is really to give communications capability to the tactical user.
For me, it's critical as a communications officer, but for the warfighter, it's even more critical because it's their lifeline.
Narrowband is used by multiple agencies. It's used from those in the White House. It's used by all the military agencies. It's used by those working Border Patrol. And the reason why is it is tactical. It can be used in any type of weather, and it can be used in any kind of urban environment.
Responsibility to supply this critical capability falls to PMW 146, the Navy's San Diego, California-based satellite communications office.
We are developing MUOS as the future system. We're maintaining UFO, or UHF Follow-On system, which is the primary constellation of satellites that we use for narrowband SATCOM right now.
Launched from 1993 to 2003, the 8-satellite UHF Follow-On constellation is on orbit, servicing the global needs of U.S. and allied forces. In addition to managing the current fleet, the PMW 146 team is also dedicated to efficiently developing the next-generation Mobile User Objective System, or MUOS, satellite constellation.
MUOS top requirements have to do with capacity and coverage and link availability. So 24 hours a day, 7 days a week, providing global coverage, the ability for a warfighter to make a telephone call over a MUOS functional terminal, and the ability to do that and send data at about 10 times more than they currently have on the system. That's what MUOS brings to the table.
This is no small task. 3 components must work together perfectly to ensure our troops receive the continuous mobile communication support they require in today's demanding environments. The on-orbit segment is connected to ground-based receiving stations that provide connectivity to the global information grid.
So PMW 146 works closely with Lockheed Martin as the prime contractor for MUOS to deliver the system. Another key member of the team is General Dynamics, who is building the ground infrastructure that supports the constellation. Our team works day in and day out with Lockheed Martin and General Dynamics.
Lastly, and very importantly, the Boeing legacy payload. That provides legacy users still the connectivity that they would have on existing satellites as they transition onto the MUOS satellites.
The ground stations, strategically located around the world in Hawaii, Virginia, Australia, and the Mediterranean, are links between the satellites and user terminals, allowing the MUOS system to provide worldwide coverage.
Really, the smarts of the system is in the ground. The advantage of that is that as things evolve and change, we can change it in the ground without requiring changes to the satellite.
It's no longer just simply making a telephone call over the satellite. I'm now having the ability to send warfighter data and calls back and forth to whoever I want them to, anywhere in the world.
As a matter of fact, the technology uses a software-defined concept, and that's what DoD is moving towards. Software has no weight. You just need to have the memory space in your terminal to allow that software to be stored, and that allows us to reduce the weight by, say, 50 to 60%.
With a wingspan of 92 feet and weighing in at over 15,000 pounds, MUOS is many times larger than any current narrowband satellite. With unique physical features such as a 14-meter diameter mesh antenna reflector, the MUOS design is poised to revolutionize current military satellite communication.
And it's a transformation in thinking about how to support a warfighter. The basic concept of MUOS is to take the cell tower, which in a cell system or along the highways and throughout the urban areas, and take those cell towers and move them to a geosynchronous orbit. So our satellite is really the cell tower.
PMW 146 not only provided the satellites, but also secured the launchers that carried the systems to orbit. Over the years, Navy satellites have been boosted by several launchers in the U.S. fleet, including Thor and the Space Shuttle. However, the majority has ridden into space atop Atlas rockets. Today, the Navy works with the Air Force to secure the launchers for the MUOS constellation. But again, the Navy will rely on Atlas for its ride to orbit.
We're the first DoD mission to launch on an Atlas 551. The 5-meter fairing part really is just due to the physical size of the MUOS satellite itself, the volume, if you will, of the satellite. And then the extra solids come about because of the sheer mass that we have. And we have a very high orbit and a geosynchronous orbit, as well as a very difficult long coast to actually get us there. So it's a pretty complicated mission.
Assuring current capability, developing next-generation communication technology, launching the future. All in a day's work, 46.
So we take a lot of pride in providing that capability and designing and building it. This is something that's critical. You see it in reports that come back from the field and the way that the generals and the admirals talk about the needs in the field.
It's critical for our warfighters. They have reliable communications whenever they need it, wherever they need it to accomplish their mission.
This is Atlas Mission Control at 19 minutes 53 seconds into the flight. We're a few seconds away from restart of the Centaur main engine. Let's go back to Matt Donovan.
And we have pre-start on fuel. And we have trickle chill pre-start on LOX. Full flow on LOX pre-start. We have ignition and full thrust on the RL-10. Chamber pressure has come up to expected levels. Closed loop steering has been enabled. And we've seen PU enabled. We're seeing indications of the expected RCS thermal conditioning firings during this burn. RL-10 chamber pressure and other engine parameters continue to look good.
As Matt Donovan just reported, the Centaur main engine has restarted for the second of 3 planned Centaur engine burns. This burn will last approximately 6 minutes. The Atlas V continues to travel in a southeasterly direction over the Atlantic Ocean. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent. Separation of the MUOS 2 satellite will occur over the Indian Ocean northwest of Australia. As a reminder, separation takes place nearly 3 hours after liftoff, or about 2 hours and 40 minutes from now. Our live coverage will terminate following our next event, MECO 2.
We're seeing expected PU control.
I'm joined again by Commander Matt Boland. Commander Boland, we've talked about the MUOS satellite and its architecture, but what about the capability of MUOS? Is it truly transformational for the U.S. military?
Yes, Steve. MUOS really should be a revolutionary capability as opposed to evolutionary capability. Right now with military UHF, dismounted users have to be stationary with a radio antenna pointing up towards the satellite. With MUOS, they'll be able to communicate on the move and beyond their line of sight, whether the other user's on the other side of a mountain or the other side of the world. Whether it's vehicles, ships, submarines, aircraft, or individuals on foot and on the move, this system is designed to bring them voice and data communication services, both point-to-point and through network connections. These capabilities did not exist with previous programs.
Commander Boland, can you explain this capability and how does it directly affect our troops in the field?
Great question, Steve, because that's really why we're all here doing what we're doing, is to support the troops. MUOS's top requirement is to have increased system capacity, coverage, and link availability. It will provide worldwide coverage 24 hours a day, 7 days a week. The ability for a warfighter to have on-demand prioritized satellite communication access while on the move and in stressed environments, and have simultaneous voice and data connectivity, that's what MUOS brings to the table. Navy-provided space-based narrowband capability also ensures reliable worldwide coverage for national emergency assistance, disaster response, and humanitarian relief.
Well, Commander, liftoff is obviously an exciting time in a mission. Can you share some of the excitement you're feeling now for the launch?
Yeah, Steve. Launch is very exciting. Any launch is very exciting, and it's the culmination of millions of hours of work by both government and contractor teams. This launch is particularly exciting for the team because the associated ground and networking system is currently being delivered. So after full acceptance of the MUOS 2 satellite, the full suite of new capabilities will be made available for operational use. After separation today, the satellite will spend the next 7 days or so transitioning to its geosynchronous orbit, and then we'll begin a thorough checkout by the combined government and contractor team before being turned over for operational use sometime next year. This will result in the initial operating capability for the MUOS system after we've verified nominal performance on orbit and the required satellite control equipment and personnel are operational.
Thanks again. I appreciate you being here to provide the insight into the MUOS program, and let's get back to the mission.
Pressure and all other RL-10 engine parameters look nominal.
This is Atlas Mission Control at T+ 24 minutes, 41 seconds into the flight. We're about a minute or so away from the completion of the second Centaur main engine burn. Let's go back to Matt Donovan.
We now have approximately 1 minute remaining in this second burn. RL-10 thrust chamber pressure is at nominal level. LOX and hydrogen tank ullage pressures continue to look good. We have MECO. RL-10 thrust chamber pressure and other engine parameters have come down as expected. 4S settling engines are on. RL-10 hydrogen pump housing pressures.
This is Atlas Mission Control at T+ 26 minutes, 44 seconds into the flight. The Atlas V MUOS 2 mission has just completed the second of 3 planned Centaur RL-10 engine burns. The mission is now in an extended coast phase, and all systems continue to operate as expected. Liftoff occurred at 9 a.m. Eastern Daylight Time. Following this 2-hour, 20-minute coast period, the Centaur main engine will be started for a third short burn. A short coast period will follow the third burn. MUOS 2 separation is scheduled to occur at 2 hours and 53 minutes into the flight. As I mentioned a few moments ago, due to the long duration of this morning's mission, we'll now conclude our launch coverage. I'd like to thank Matt Donovan for his support in today's broadcast, and I'd also like to thank Navy Commander Matt Boland from the Navy's Communications Satellite Program Office. We'll conclude our live coverage with another look at liftoff. For more information about the Atlas V rocket, please visit our website at www.ulalaunch.com. Again, for more information about the Atlas V, visit our website, www.ulalaunch.com. I'm Steve Agate. On behalf of the entire launch team, thank you for joining us, and have a good day. We have main engine start. We have ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the second Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You'll be hearing the voice of Matt Donovan providing launch vehicle
and we are in
data.
the zero angle
Let's
of
listen
attack
in for
phase of
mission
flight.
progress.
Your roll program has been completed.